Hello everyone, welcome to our third video of our gRPC playlist, and in this video we are going to cover the differences between REST, gRPC, WebSocket and Kafka. We are going to see where to use what. So without wasting any time, let's get started and study. So first of all, let's talk about the protocols. So REST use HTTP 1.1, gRPC using HTTP 2, WebSockets are using TCP and Kafka is using TCP. So let's make a comparison between REST and gRPC first of all. HTTP 1.1 is slower than HTTP 2. The difference is pretty simple. HTTP 2 is using multiplexing and the headers are going to be compressed, so that's why it is making everything faster than the HTTP 1.1. Secondly, let's move to our WebSocket. So TCP is faster than the HTTP. So it is of course going to be faster than HTTP 1.1 and HTTP 2, and Kafka is also working on TCP. So it means that Kafka and WebSockets are faster than REST and gRPC. It's a simple thing because the protocols are going to be different. Now let's move to the second point that I mentioned it here. When you're using REST, you are transferring the data in the format of JSON and XML. In gRPC, you are using protobuf and binary. In WebSocket, you are using text and binary. And in Kafka, you are again using text and binary or binary and JSON. So again, let's make a comparison. So when you are using JSON and XML in REST and you are using HTTP 1.1, the protocol is slow and you are a JSON and XML. But in gRPC, what have changed? We are using better protocol HTTP 2 and we are transferring the data in the protobuf binary. It means that we are sending the data in binary and our protocol is fast. That is why gRPC is faster than the REST. But let's see, is it faster than WebSockets? So you are seeing that it is using TCP. The protocol is very faster than the HTTP. And again, WebSocket have the functionality of both. You can also transfer the text, you can also transfer the binary. So WebSockets are faster than the gRPC. But now let's move to the Kafka. Again, Kafka is using TCP and binary and JSON. So it makes is faster than REST and gRPC. Okay, so we are not sure about the WebSocket and Kafka, but we are very damn sure that the Kafka is faster than the REST and gRPC. The purposes are different, so please don't be confused. Now let's move to the streaming part. As you can see, REST did not support any streaming. You cannot stream in REST. So let's understand it with an example. What is actually streaming? So suppose if you have to upload a 1 GB file from a client to a server. Suppose you are uploading a video on YouTube. Then what will happen? The one way is to directly upload a 1 GB video to the client, to our server. And the other way is to provide that video in small chunks. In a simple stream of thread, you want to provide simple packets. You want to provide that thing in a thread of packets. Now what is happening? In the REST, you cannot perform it. But in gRPC, you can do it. This is why I'll say that the gRPC is providing streaming. REST can also provide streaming, but very limited. So we'll just simply say it's like a no streaming platform. In WebSockets also you can provide a streaming. Kafka is a different architecture. So let's talk about the states. So I mentioned that REST is stateless. So what that means is, like suppose you want to update a data, when the data is updated, then our connection is going to be lost. If you want to make if you want to make some other change, you will hit a different API call, or you will make a different connection and you will again perform the task. In the gRPC also happening the same thing, but gRPC supports the streaming. So let me just solve the confusion. Suppose there is a connection, and now you can send stream of 10 images from that connection. So this is our request, stream of 10 images. It will go to the server will get those images and they will return the responses. But after those 10 images is uploaded, again the connection is going to break. This is what our stateless is. Remember, gRPC is also stateless. It will also make a new connection if you have to again upload the 10 images. Now let's come to the WebSocket. WebSocket make a stateful connection between the client and the server. So suppose if you are on a live chatting application, both the people are on the screens right now, they are chatting. Like user 1 is sending the message to user 2, user 2 is sending to user 1, they are chatting. And what is happening? Like suppose the user 2 put the phone down and not messaging, still the connection is present right now. The connection didn't break. Like there is a thing also in the WebSocket where you can make a connection for 10 minutes, something like that. Okay, like if they're continuously checking, the connection is going to increase the size. This is what WebSockets provide. They are maintaining a stateful connection. gRPC is maintaining a stateless connection. In Kafka, it is saying it is persistent. What does it mean by the persistent connection? So what is happening? Like when you are sending a message from producer to a consumer, you are sending any messages like stream of data, or you can just simply say some packet, some sort of a JSONs you are transferring. Suppose the consumer is down at that time. Consumer is not working at that time. Still, the messages are not going to be lost. They are going to present in that queue. When the consumer will come up, consumer can use those messages. So producer is going to push the message in the queue, and when the consumer is going to come up, those messages are going to be consumed by the consumers. This is what a persistent connection. The data is not going to be lost. In the REST, gRPC, in the WebSockets, data is going to be lost at the time when the both server and the clients are not present. They both have to be online at the same time, then only we can make our work done. In the Kafka, the messages are going to be stored in a queue and that can be consumed later. This is the whole difference. Now let's come to the use cases where to use REST, gRPC, WebSockets and Kafka. Now we are going to talk about the use cases. So let's understand about the REST. So if you want to perform any CRUD operations, suppose let's say that you want to update a user. You have a mobile application and you want to update the images, or you want to change the name of a user or something like that. You will just simply go to that profile section, you will just change the user and you will press the save button. At that time the put API call will go and it will change the data. If you want to make a new entry, the post API call will go. It's simply just changing the user data, something is added to your cart. That is all are the CRUD operations we are using, performing get APIs, post APIs, put APIs. This is known as the REST CRUD operations. It's just simple APIs. When we have to make, we will go for the REST. Now, what we want in gRPC, why gRPC comes here? If you want to make our system fast, let's take one more example. Suppose you have a screen, and in that screen, what you want this time, you want to upload a 1 GB file from our front end to our backend server. So what we'll do in this time, you don't want to upload a complete 1 GB file. It will take a lot of time. So in that case, you can go to gRPC. In the gRPC, what will happen? The data will go in some small chunks and it will reach to our server. This is the first use case of a gRPC. Second use case where you can use. So I told you for that second use case, let's understand it with an example. Suppose this is my front end. Let me just change my pen first of all. So this is my front end. It makes a REST API call. Suppose the front end wants to show the post and the comments. And in my backend, there are two services. First is our post service and second is our comment service. We want to show the post and comments both on the front end right now. So what will happen in that scenario? First of all, the API will go to the post and it will take the data related to post, and this internal API will get us a post ID and we will find the comments related to all those posts. It is an internal API call. So technically what is happening, previously we are using the REST APIs calls. Now if we want to increase the system speed, what we can do, we will just shift to gRPC, because gRPC, the data is going to transfer in the binaries and we can directly make a function call and we don't have to make an API. So what we will do, we'll just simply use a gRPC thing, and now what we can do, we can just simply provide the data here from our comment to post and then simply return the data in the REST API. So internally, when you have to make internal APIs, you can simply use gRPC. I also mentioned the cross language. So I also explained you, when you have a Go language server, you have a Java client, you can make a call. You can make a function call of a Golang server to our Java client. This is how gRPC is powerful. Now let's move to our WebSocket. So WebSocket is used when you are doing a live chatting between like two users, user 1 and user 2. They are doing a live chatting right now. We will simply use WebSocket. When you are communicating in a Google Docs, two people are collaborating at the same time, we will simply use a tunnel of WebSockets and we are able to do that. and we can also use in an online game. Suppose there is a PUBG server and like 8 people are playing in a same game, so they are all are connecting with the help of a WebSocket. Now let's come to the Kafka. The use cases of Kafka are a little different right now. So Kafka simply solve the cases, like suppose there are 10,000 transactions happens in a day, and you want to push those transactions to the data team. You want to like provide those transactions. So you cannot directly provide those 10,000 transactions to the data team. Either you can provide a zip file that and provide to the data team. This is what's happening in like after like 10 years back. That was happening. You just provide a zip file. Now the systems have changed. We have shifted to event-driven architecture. Now what happened? You just simply push those transactions into a Kafka, and they will go into a queue that is a persistent queue. The data will be stored. So suppose the consumer of a data service is down right now. Nothing to worry. When the service will come up, the transaction is going to be consumed by the data or data team or data service. This is how the Kafka is used. Kafka is also used in notification systems, where you just simply push those notifications into the Kafka queue and they are going to be consumed by the respective notification service. This is how the Kafka is working. So this is all the use cases where you can use REST, gRPC and WebSocket and Kafka. I hope you understand them. And now in the next video, we are going to study about the implementation of the gRPC in the Java. Thank you for watching me, and bye bye.